Have you ever wondered how a tiny chip can power the world? Today, we're diving into the fascinating world of computers. From their humble beginnings to the advanced machines we use today, we'll explore their definition, history, operating systems, some mind-blowing facts, and what the future holds. So grab your favorite snack and let's get started. Let's take a trip back in time. The history of computers is a fascinating journey that spans centuries, beginning with early calculating devices like the abacus in ancient times. The 19th century saw significant advancements with pioneers like Charles Babbage, whose design for the analytical engine laid the groundwork for future machines by introducing concepts like the stored program and sequential control. Charles Babbage, an English mechanical engineer and polymath, originated the concept of a programmable computer. Considered the father of the computer, he conceptualized and invented the first mechanical computer in the early 19th century. After working on his difference engine, he announced his invention in 1822, Hamann Manusal mechanical computer, produced in Germany by the D2 company between 1953 and 1959. Konrad Ernst Otto Zuse, 20 June 1910 to the 18 December 1995, was a German civil engineer, pioneering computer scientist, inventor, and businessman. His greatest achievement was the world's first programmable computer. The functional program-controlled complete ZK became operational in May 1941. Thanks to this machine and its predecessors, Zuse is regarded by some as the inventor and father of the modern computer. Fast forward to the mid-20th century, the advent of electronic computers marked a revolution. Machines such as the ENIAC were massive, room-sized devices that could perform thousands of calculations per second. The 1970s and 80s ushered in the personal computer revolution, making computing accessible to the general public with iconic models like the Apple II and IBM PC. This democratization of technology transformed homes, schools, and workplaces, paving the way for the interconnected world we live in today, where computers have become essential tools in nearly every aspect of life. First things first, what exactly is a computer? In simple terms, a computer is an electronic device designed to process, store, and retrieve data, capable of performing complex calculations at remarkable speeds. At its core, a computer consists of several key components: the central processing unit, CPU, which acts as the brain, executing instructions and performing calculations; random access memory, RAM, which serves as temporary storage for data in use; and long-term storage drives, such as hard drives or solid-state drives, where files and applications reside. Computers come in various forms, including supercomputers for advanced scientific calculations, personal computers for everyday tasks, and embedded systems found in appliances and vehicles. Equally important is the software that runs on these machines, allowing users to perform tasks ranging from word processing to gaming. Overall, computers have revolutionized how we work, learn, and communicate, making them indispensable tools in today's digital age. The first computers emerged in the mid-20th century, marking a significant leap in technology. One of the earliest electronic computers was the ENIAC, Electronic Numerical Integrator and Computer, completed in 1945. Weighing over 30 tons and occupying an entire room, the ENIAC was capable of performing thousands of calculations per second, a groundbreaking achievement at the time. It used vacuum tubes for processing and was programmed through a complex system of plug boards and switches. Following the ENIAC, the UNIVAC-1 Universal Automatic Computer became the first commercially available computer designed for business applications and data processing. These early machines laid the foundation for modern computing, introducing concepts such as programmability and data processing that would evolve dramatically in the following decades. Their development marked the beginning of a technological revolution that would eventually lead to the compact, powerful computers we use today. The personal computer revolution of the late 1970s and 1980s transformed the landscape of computing, making technology accessible to the general public. This era began with the introduction of the Apple II in 1977, a user-friendly machine that featured color graphics and an open architecture, allowing users to expand its capabilities. Shortly after, IBM entered the market with the IBM PC in 1981, which set industry standards and solidified the personal computer's role in homes and businesses. These machines were equipped with operating systems like MS-DOS and later Windows, enabling a wide range of applications from word processing to gaming. The rise of affordable microprocessors and software development further fueled this revolution, leading to a surge in innovation, entrepreneurship, and the establishment of the home office. By democratizing access to computing power, the personal computer not only changed how people worked and communicated, but also laid the groundwork for the digital age, influencing every aspect of modern life. Now let's talk about operating systems, essentially the software that makes computers usable. Think of it as the conductor of an orchestra, managing hardware and software resources. Operating systems, OS, are essential software that manage hardware and software resources on a computer, acting as an intermediary between users and the machine. They provide a user-friendly interface, allowing individuals to interact with the computer through graphical elements or command lines. Among the most widely used operating systems, Microsoft Windows stands out as the dominant player in personal and enterprise environments, known for its user-friendly interface and extensive software compatibility. With versions like Windows 10 and the recently released Windows 11, it caters to a vast array of users, from gamers to professionals. On the other hand, Mac OS, developed by Apple, is praised for its seamless integration with Apple devices and its robust performance in creative applications, making it a favorite among graphic designers, video editors, and musicians. Linux, an open-source operating system, offers unparalleled customization and flexibility, attracting developers and tech-savvy users who prefer a more hands-on approach. Additionally, mobile operating systems like Android and iOS have revolutionized how we interact with technology, powering billions of smartphones and tablets worldwide. Each of these operating systems brings unique features and capabilities, catering to diverse user needs and preferences, thus shaping how we experience computing in our daily lives. Ready for some fun facts? Here we go. Did you know the first computer virus, called Creeper, appeared in the early 1970s? Here's another one. There are more than 1.5 billion computers in use worldwide today. And lastly, the world's first computer programmer was Ada Lovelace, who worked on Babbage's early machines. Computers are not only powerful tools, but also the source of some fascinating trivia that highlights their impact on our lives. For instance, the first computer virus, known as Creeper, was created in the early 1970s and was designed to move between computers on ARPANET, displaying the message, "I'm the Creeper, catch me if you can." Additionally, it's estimated that there are over 1.5 billion computers in use globally today, ranging from massive supercomputers to portable laptops and smartphones. Remarkably, the world's first computer programmer was Ada Lovelace, who worked on Charles Babbage's early mechanical computers in the 19th century, laying the groundwork for modern programming concepts. Another intriguing fact is that the term bug in computing originated from an actual moth that caused a malfunction in the Harvard Mark II computer in 1947. These fun facts not only showcase the quirky history of computing, but also remind us of the profound ways computers have shaped our world. So what's next for computers? The future is incredibly exciting. We're talking about advancements in artificial intelligence, quantum computing, and even brain-computer interfaces. AI is already transforming industries, enabling computers to learn and make decisions. Imagine what's possible in the next decade. Artificial intelligence, AI, is poised to revolutionize the way we interact with computers and technology, transforming industries and enhancing everyday experiences. At its core, AI involves creating algorithms and systems that enable machines to perform tasks typically requiring human intelligence, such as understanding natural language, recognizing patterns, and making decisions. From virtual assistants like Siri and Alexa that help manage daily tasks, to sophisticated machine learning models that analyze vast amounts of data, AI is already integrated into numerous applications. In fields like healthcare, AI is improving diagnostic accuracy and personalizing treatment plans, while in finance, it aids in fraud detection and risk management. The development of AI technologies continues to evolve, with advancements in deep learning and neural networks leading to more capable systems that can learn from experience and adapt over time. Furthermore, as the Internet of Things, IoT, expands, everyday devices will become smarter and more interconnected, leading to more smart homes and cities. Together, these advancements hint at a future where computing is not only more powerful, but also more intuitive and integrated into our daily lives, reshaping how we interact with technology. As AI becomes increasingly prevalent, it raises important ethical questions about privacy, job displacement, and decision-making, making it essential to navigate its integration thoughtfully and responsibly. Quantum computing promises to solve complex problems in seconds, something traditional computers can't do. It could revolutionize fields like medicine and cryptography. Quantum computing represents a groundbreaking shift in computational power, leveraging the principles of quantum mechanics to process information in fundamentally different ways than classical computers. Unlike traditional bits, which can be either 0 or 1, quantum bits or qubits can exist in multiple states simultaneously, thanks to phenomena like superposition and entanglement. This allows quantum computers to perform complex calculations at astonishing speeds, making them particularly well suited for tasks such as cryptography, optimization problems, and simulations of molecular interactions in chemistry and material science. Major tech companies and research institutions are racing to develop practical quantum computers with the potential to solve problems that are currently intractable for classical systems. However, significant challenges remain, including error rates and qubit coherence times, which researchers are actively working to overcome. As quantum computing continues to evolve, it promises to unlock new frontiers in technology, science, and industry, reshaping our understanding of what is computationally possible. And then there's the potential for brain-computer interfaces, which could allow us to interact with computers using just our thoughts. It sounds like science fiction, but it's closer than you think. Brain-computer interfaces, BCIs, represent a groundbreaking frontier in technology, enabling direct communication between the human brain and external devices. By interpreting neural signals, BCIs can translate thoughts into actions, allowing individuals to control computers, prosthetics, or even robotic limbs using just their mind. This technology holds immense potential for improving the quality of life for people with disabilities, enabling them to interact with their environment in ways that were previously unimaginable. Research in BCIs has progressed significantly, with applications ranging from therapeutic tools for neurological disorders to enhancing cognitive abilities and gaming experiences. However, challenges such as signal clarity, ethical considerations, and the need for non-invasive methods remain critical areas of focus. As advancements continue, BCIs could not only revolutionize medical treatments, but also transform how we interface with technology, merging human cognition with machine intelligence in unprecedented ways. Wow, what a journey through the world of computers. From their definition and history to operating systems and the thrilling future ahead, we've covered a lot today. What aspects of computer technology excite you the most? Let me know in the comments below.